Hey guys, welcome back. In this video, we're going to be talking about wide area networks. Now, it's interesting because when we talk about wide area networks, it's kind of like a chicken versus the egg, because there's so much to a WAN that sometimes it's hard to grasp because there's just so much there. But at the end of the day, a wide area network is what allows us to connect multiple LANs or local area networks together into what appears to be one large network. So let me draw this out so that we're all on the same page. So let's imagine here that we have a headquarter office, and inside that headquarter office we have our own local area network, right? So let's just say that you're using 192.168.1.0. So you have a /24 network, and I know we haven't really gotten into subnetting yet, but you have this entire address space that you can use in this local office. And you have a bunch of users here that are all going about their daily duties, and they're all doing their job, and they're emailing each other, whatever it may be. And you have a internet connection, so we'll say iNet here. So you have an internet connection, let's say it's from AT&T, and this is what you're using to essentially gain Office to maybe some services like Office 365. So we'll say this is how you get access to your cloud email or something like that. Now, this is all fine and dandy until the day comes where now you need to expand, right? You need to get to the point where, hey, we're opening up a new store location, or we've gotten to the point where, we want a small satellite office on the other end of the country. Maybe this is in New York and you want a satellite office in California, or vice versa. It doesn't really matter. So now you need a site 2. So we open up another site and we build an entirely different local area network, right? And let's just say that this is 192.168.2.0 because we like being consistent. So we want to put site 1 on a .1 subnet. We want to put site 2 on a .2 subnet. It makes our OCD happy. Now you all have your own set of users here, and they're all going about their daily duties, and they're all doing their jobs, and they're emailing each other, and they're doing what they need to do, and they have their own internet connection. So we'll draw this in over here. So these guys have their own iNet connection. And let's just say that this is how they gain access to, the same Office services, Office 365, which again, right now we're not talking about cloud versus on-prem, but we'll get to that in another video. So this is how they get access to Office 365, but there's a problem. They might be able to email each other through, Office 365 because Microsoft has their own cloud services and that works. They might still be able to get to, OneDrive, for example. So you might still be able to share Office documents. But what happens now if I need to print over here? So what happens if all of a sudden this user here needs to be able to print or access a specific server resource? So maybe there's a server over here, and maybe this server is a file server, or maybe it's some kind of web server, or maybe there is a server here, and maybe this is our portal. Maybe this is our employee portal or something like that, where these users need to be able to access these resources that are on-prem in their own office. Well, now we have a problem because we can't just access that over the internet. We need a wide area network. We need the ability to connect these two local area networks together. And this is exactly what a WAN does. And there's different WAN technologies in order to make this possible. In theory, there are many different technologies that I could just leverage the internet in order to do this. I wouldn't need a separate technology or a separate type of device or anything like that. But that's a little down the road. I'll probably address that in the next video. In this video, I just want you to understand what a WAN is. So what a WAN is a WAN would be a connection that comes in, and typically this is going to be provided by an internet service provider. So let's just say again, here was AT&T. Let's say that over here was AT&T as well. This WAN connection could be AT&T. Maybe it's Verizon. Maybe it's somebody else. Doesn't really matter. And so what happens now is the ISP comes in and says, well, we will give you the ability. We will give you almost like your own private internet that doesn't have access to Google. It doesn't have access to all these other services, but what it is going to do is it's going to allow your two offices to be able to connect together. So now this server, when it wants to reach this other server, can connect through the WAN cloud and connect into this server. When, Betty over here wants to send a job to the printer that lives in this office over here, she can send a print job, and that will go over the WAN cloud. It will come through all of those devices. It will come into that local area network at site 2, and it will come out on that particular printer. And the reason is because we will be able to route, and again, we'll talk about some of that stuff later on in the course, we will be able to route between these two different offices. So everybody in this office knows that 192.168.2 is over in this site over here. And in order to get there, you have to send your traffic through the WAN cloud. So that's essentially what a WAN does. It allows us the ability to connect multiple different offices together through an internet type of connection. It's not necessarily always the internet. It can be, but it's not always. Now, there are different types of WAN topologies. As you can see here, there are point-to-point, there's hub and spoke, and I want to go through just in a couple minutes what those are. So let me redraw here. So we're going to say HQ, and we're going to say site 1, so say S1 or S2, doesn't really matter. What a point-to-point connection is these two sites being able to connect directly together. Now, we're not stretching, you might sit there and say, well, how would that work? I have one office in New York and I have another office in California. You're not stretching a physical cable between these two offices. What's happening is, virtually speaking, let me draw this in another color. What's virtually happening is your two offices are connected together, but your traffic is actually going up to the ISP, and then the ISP is sending it right back down to that other site. The ISP is not sending your traffic out to Google or anywhere else. So the ISP is allowing you to connect your headquarters site directly to your second remote site. So it's a point-to-point. Your headquarter office would not have access to another particular site because, again, it's point-to-point. Now, where this evolves is what we would call a full mesh. So now let's say, let me pick a different color here. Let me go back to blue. Let's just say that you had site 1, you had site 2, and you had site 3. So I know we're drawing them in a little bit out of order, but we'll just go with it here. Let me erase the ISP here. We'll just erase this and redraw. Now, there's two ways that we can essentially evolve this network. Now, a point-to-point would be just this headquarter office connecting to this one site. But we have other sites that we need to connect to. So we can do two additional things. Well, I got my pen in my hand. We can do two additional things. We can go with what's called a full mesh, which is where each of these sites would be a full connected point-to-point network. And what I mean by that is HQ would connect to site 3. That would be a point-to-point. HQ would connect to site 2. That would be a point-to-point. Site 2 would connect to site 1, and site 1 would connect to site 3, and site 3 would connect directly to site 2. So even though individually these would be point-to-point connections, we would count this as what we would call a full mesh configuration, because each site has the ability to get directly towards each other. So I should say send direct traffic between each other. You don't have to go around. You don't have to route traffic through somebody. It's a full mesh, and this is really what offers the most redundancy. This is what offers the I would say the best performing, because you don't have to go through somebody. And when I say go through somebody is there's another, let me redraw this again. There's another evolution of this. So we'll say HQ. This time we'll put them in order. So we'll say site 1, say site 2, we'll say site 3. There's another evolution of a point-to-point network, which is what we call a hub and spoke. Now, a hub and spoke network is almost like, think of a bicycle wheel where you have the center of the bicycle wheel, you have this outer ring, and then you have all of these different connections, what you would call the spoke. So this middle here is what you would consider the hub, and then all these lines is what you would consider spokes. So a hub and spoke network is the same thing with your headquarter office or a specific location acting as this center of the wheel. So you would have, again, similar point-to-point connections. So you would have HQ that connects directly to site 1, 2, and 3, but sites 1, 2, and 3 do not connect to each other like you would in a full mesh, and they have to send their traffic through headquarters. So in order for site 3 to get to site 1, the traffic would look something like this. And it would go through HQ, and it would come back, and it would get to site 1. Remember that this is all being provided by the internet service provider. So even though I'm drawing you a bunch of lines that makes it look like these things are directly connected, they're really not. So in real life, the topology looks more something like this, where you have HQ, and HQ is connected out to the ISP. And then over here on the other end of the world, you have site 1, and site 1 is connected to the ISP. And the same thing with site 2 and site 3. So they're all connected to an ISP. And again, depending on the technology that we're going with, it could be the same, it could be the different ISP, it doesn't really matter. P, not a D. And these ISPs have their own internal network structure. So inside here is their LAN. So all of these internet service providers have their own interconnections. And all they're doing is they're saying, look, send us your traffic and we'll take care of it that it comes out on the other end. So in most cases, a service provider like this, in a network like this, the ISP is going to take care of this. Or again, if you're just going to use the internet, you can use your own technologies, which I'll get into. Now, I drew this for a specific reason, because as I finish up this video, I want you to understand the difference between a single and a dual homed network. What do I mean by that? Well, here, let's just say that all of these internet service providers are AT&T. This would be a single homed network, meaning if AT&T has a problem, then your WAN goes down, your internet goes down, your connections to the outside world go down. If you have a dual homed network, that means that you have, let's pick a different color because colors are fun. If you have Verizon over here and you have a secondary connection going out to Verizon as a secondary WAN that's connecting these guys together, and AT&T has a problem, well, you still have a redundant connection between headquarters and site 1 or site 2 or whatever site you want to connect to, because you have now a dual homed network. You have multiple different providers. Now, what I want to draw you very quick to kind of bring this together into one view is an actual network that I designed for a company. So we had our headquarter office, and we had a site in California. So we're just going to say California, and we had a site in New York. And well, let me draw this again here because I'm messing it up. My drawings are atrocious. So we'll say we had California over here. And then we had New York. I don't know why I drew a T instead of a Y. This site was in Connecticut. And each site had their own internet. So we're going to draw an internet. I know that looks atrocious, but we're going to draw internet. I know that my writing is atrocious, but we're going to say internet. Now, internet was from all different service providers. So our internet, over here may have been from Verizon. The internet over here was from AT&T. The internet over here was from some local provider. But the bottom line is that we had internet access. Once you're out on the internet, you can get to other sites. You can get to other locations. In addition to this, what we had was we had another ISP. We're going to put ISP here, and I'll say ISP WAN, because I don't want to get into what it is at the moment, because we'll explain that in another video. So we had an internet service provided WAN that connected all 3 sites together. And this was great. But in this case, it was a single homed configuration, because if this ISP went down, there's no way that I would have been able to overcome that. So what we did was we dual homed our WAN by using DM. I said I wasn't going to do this, and here I am doing it. So over here we had MPLS, and this was internet service provided to us. So we had an MPLS connection here. And then over here we had a DMVPN that used the internet to virtually connect all of these different internet connections together between our sites. So what we would do is if our main site went down, so if our MPLS network crashed, if the internet service provider had a problem, and I can't remember who this was, this may have been AT&T, it didn't matter because our DMVPN would kick in as a secondary mechanism to connect these sites together, and it was redundant. It was instant. We may lose a packet or two. In fact, we would test it once a month. We'd actually be on a phone call, an IP call, and we'd be talking to each other through all these different sites on a conference call, and we'd actually have somebody go over there and cut the MPLS connection, and not physically, but unplug it or shut it down. We obviously did this on a weekend for redundancy testing, and everything continued to function because we had it configured to automatically fail over to our DMVPN. Now, I'll explain in the next video what these are, and I won't explain how to configure them. It's way outside of this course, but I'll explain a little bit more of what they are. And so this is how you can have a dual homed network that allows these different sites to connect. So I hope you guys enjoyed this video, and I'll see you all in the next one.